Right, so I'll be solving the practice test for the chapter 5 for the pre-calculus 12. I'll try my best to explain in vocal words to explain the thought process of each question. Let's start with the first question. So you're given an equation and I want to find some specific aspects of the graph. There are a couple of things we can do. We can try to find um, we can look at the parameters of the equation and fill in the table, or I can use the graphing calculator, like Desmos, to check the amplitude, period, and x-intercept. In this solution set, what I'll do is I'll try to do it um, without the calculator first, and then I'm going to check using the graphing calculator. So let's look at the first equation. Y is equal to negative square root 2 sine of 1 over 2 times x plus pi plus 1. So I know that my a value is negative square root 2, b value is 1 over 2, c value is pi, and lastly d value is equal to 1. First, a is negative square root 2, so I know that my amplitude is the absolute value of a, which means that it's going to be square root 2. I know that my b value is 1 over 2, so I can find the period by using this conversion, 2 pi over absolute value of b. So in this case, 2 pi divided by 1 over 2. I like to do it when it's a fraction over fraction kind of situation. I just like to treat it as a division. 2 pi divided by 1 over 2, which is 2 pi times 2 over 1. Therefore, this is 4 pi. Lastly, I need to find the x-intercepts. To find the x-intercepts, I need to solve the equations and whatnot, and it's a bit problematic. Um, for this case, I think, however, I can think of it as a transformation. This function is transformed in the negative direction to the left by pi, and then it has a period of 4 pi. So I think it may be something like negative pi plus 4 pi n, but I'm going to check using the calculator. Let's use Desmos. I'm going to type in the equation. Y equals negative square root 2 sine of 1 over 2 times x plus pi plus 1. That's right. So I'm going to first check that my amplitude and the period. Well, the period seems like two maximums are 4 pi from each other, so the period is 4 pi. That seems good. And also the maximum is 2.41421. And then my minimum is negative 0.41421 divided by 2, which is 1.41421. And square root 2 is indeed like that. So I'm happy with my amplitude of square root 2 as well. Finally, my x-intercepts seem to be negative pi over 2, and then pi over 2, and the next one is 7 pi over 2, and probably 9 pi over 2. So from here you can see, while my first ones are negative pi over 2 and pi over 2s, and it seems like it's repeating every 8 pi over 2, right, which is 4 pi, which we obviously know from the period that it's 4 pi. Therefore, my x-intercept would be negative pi over 2 plus pi, negative pi over 2 plus 4 pi n, as well as pi over 2 plus 4 pi n. Let's write that down. So that's part A done. Let's go to part B. Y equals negative tangent of pi over 4 times x minus 2 plus square root 3. I need to find the period and the midpoint and the x-intercepts. First of all, let's write down the values. A equals negative 1, B equals pi over 4, C equals -2, and D equals square root 3. So, first thing is that my B value tells me the period. Well, period, in this case, for tangent, is not 2 pi over b, it's going to be pi over b. That's going to be pi divided by pi over 4, which is, once again, pi divided by pi over 4, which is pi times 4 over pi. Therefore, the period seems to be 4. And what about my midpoint? Well, I find the midpoint quite easily just by looking at the C value and the D value. Well, C tells me the phase shift, and D tells me the vertical displacement. So if C is -2, my phase shift is +2, and it seems like there is a vertical displacement of positive square root 3. So I think the midpoint should be in 2 comma square root 3. Once again, I'm going to check the answer by using the calculator pretty soon. And then also we need to find the x-intercepts. I think I meant to say vertical asymptotes, so I'm just going to switch it like that. Well, without the graph, like without using the graphing calculator, well, the usual vertical asymptote is between the two midpoints, and it seems like the midpoint is 2, and the period is 4. So therefore, it means that if I just draw a number line, there will be a midpoint at 2, and another midpoint probably at 6 because the period is 4, which means there must be a vertical asymptote at 4. So I think the vertical asymptotes will be will be 4 plus 4n. Once again, I'm going to check using the graphing calculator. Y equals negative tangent of pi over 4 times x minus 2 plus square root 3. So, first of all, let me check the period. Well, it seems like the graph is repeating every now and then, every 4 steps. 0 to 4, that's one wave. 4 to 8, that's one wave. So I like that the period is 4. Also, I found the midpoint to be 2 square root 3. And let's see, yes, it seems like the midpoint is indeed in 2 comma square root 3. Finally, let's find the vertical asymptotes. Well, the first vertical asymptote should be at 4, that's right. And then plus 4n, so plus 4, 8, 12, all seems pretty nice. I'm happy with my result. So that's part B done. Let's move on to question number 2. For the given graph, find the equation of the function. So for this question, it seems like it's a sine or cosine graph. And as I told you in class, I prefer to just go with the cosine just because, in my opinion, it's just simpler that way. I'm going to use the maximum, 2 consecutive maximum points, as well as a midpoint between that to check the amplitude, the midpoint, and the period. So let's first look at the amplitude. Amplitude is found by finding the max minus min, max value minus the min value divided by 2. So in this case, maximum is 5, min value is -1. So the amplitude is 3, which tells me that A is equal to 3. I also know the midpoint. Doing the similar fashion, it's maximum plus minimum divided by 2. Which tells me that the D value is 2. Finally, the period is found by finding the difference between the two consecutive maximum points, the x value of the difference. So it's going to be 9 pi over 4 minus pi over 4, which would be 8 pi over 4, which is 2 pi. So this one tells me that from the formula, period is equal to 2 pi over b. Period is 2 pi, so I think b is equal to 1. Finally, I need to find the phase shift. Well, I find the phase shift because my usual cosine graph will reach the peak when you start the graph at x equals 0, right? And it seems like I can move to the right by pi over 4, and I'll match the phase shift. So in my opinion, the phase shift should be pi over 4, which tells me that my c value would be minus pi over 4, or negative pi over 4. Just a reminder that the phase shift can be any different values. It can be minus 9 pi over 4, or plus 7 pi over 4 to the 7 pi over 4 to the left. Or you can even make this into a sine graph, or a negative cosine graph, or negative sine graph, however you want. However, in my opinion, I just think it's easiest to go with the cosine graph, and it's okay to go either way. So my final answer would be y is equal to 3 cosine of b is 1, so that's just x minus pi over 4, close bracket, plus 2. And once again, let's check the calculator. Let's check with the calculator to see if the answer is correct. If you know what you're doing, you never have to worry about whether you get the right answer or not. 3 cosine of x minus pi over 2, close bracket, plus 4, close bracket, plus 2. So my first maximum is pi over 4, 5. Second minimum, the first minimum is 5 pi over 4, negative 1. And finally, 9 pi over 4, 5. So I found the correct equation. Moving on to the question number 3, this is a tangent function. So let's look at some characteristics of this tangent function. Well, I do notice that the vertical asymptote is happening at x equals 0, and then 2, and then 4. So that means that we have 0 plus 2n as my vertical asymptote. So what do I know about this? What do I learn from this vertical asymptote? Well, the first thing is that we know that the period is 2, because each wave happens every 2. 0 to 2, 2 to 4, and so on. So if my period is 2, what do I know about the v value? Well, remember that we said period is equal to pi over b. That's 2 is equal to pi over b, which means that b would be equal to pi over 2. So I found one value. Now let's also try to find the phase shift as well as the vertical displacement. Because I know that the period is 2, then I know that the middle between 0 and 2, which is the vertical asymptote, the middle would be where the midpoint is. So that's right there. So it seems like this point has the coordinate of 1, comma, negative 2. So I think that midpoint of 1, comma, negative 2 tells you two things. Well, first, that c is equal to negative 1, because you do horizontal translation to the right by 1. And also, d is equal to negative 2 because you do a vertical displacement of negative 2. Putting all together, I think we have an equation, y equals tangent. And also finally, this graph, it seems like it's going upwards, so I think the a value would be positive. So that will be y equals tangent of pi over 2 times x minus 1, close, minus 2. Once again, let's check the answer by plugging into the decimal. See if you get the same graph. Let's turn this off. Y equals tangent of pi over 2, open bracket, x minus 1, close, minus 2. It's a bit harder to see, so let's zoom in a bit. Well, indeed, it seems like we have the vertical intercepts at every 0, 2. You can see that by changing the grid line like that. So yes, there's a vertical asymptote at 2, at 4, and 6. That's matches. And finally, we also have 1, -2 as my midpoint. So I'm happy with my graph. Question number 3 completed. Move on to question number 4. Solve the following equations. So let's look at the equation here. The first one, we're going to solve it graphically. Graphically solving the equation means we're going to plot the graph y equals left hand side, y equals right hand side, and we're going to find the value of x-intercepts. Value of the points of intersections, the x value of the points of intersections. So my plan is to graph y equals left hand side, which is -2 sine squared of x. And also I'm going to graph the right hand side, cosine of x minus 1. So let's go to decimal. Just making sure that by default everything is radian mode. In this test, I'm not going to ask any questions in degrees mode, so everything will be in the radian mode by default. -2 sine squared of x. So I'll graph y equals cosine of x minus 1. So let's identify the x-intercepts, points of intersections. I see one here, I see one here, I see one here, I see one here. It seems like it's repeating. 0, 2 pi over 3, 4 pi over 3, 2 pi. 8 pi over 3, 10 pi over 3, 4 pi. Blah, blah, blah. All right, well, we have multiple solutions here. So let's write a few of them, and then we can try to find the pattern to it. So the first one was 0, and then it was, 2 pi over 3. And the next one was 4 pi over 3. And 2 pi, and so on. Well, I think there's an obvious pattern here. It seems like there's an answer every 2 pi over 3 after 0, because 2 pi is just 6 pi over 3 as well, so it just continues in that order. So I think the general solution would be 0 plus 2 pi over 3, and it's okay, of course, to say 2 pi over 3 and just like that. So graphical solution is much easier than the algebraic solution, which we'll do right now. Okay, so we have this awful equation, 2 sine of pi over 2 times x minus 3 close bracket plus 6 is equal to -2 sine. Alright, that's a lot of work. So let's write it down first. So the first step I'm going to do is I'm going to get rid of that awful looking sine of something. I don't want to see that. So I'm going to represent u to be sine of pi over 2 times x minus 3. So now my equation looks much simpler. 2u plus 6 is equal to -2u plus 4. Now we simply solve this equation u for u. I'm going to add 2u on both sides, so I get 4u minus 6 on both sides, so that's -2. Right, I get u is equal to -2 over 4, so -1 over 2. At this point, I bring back the sign. There's going to be sine of pi over 2 times x minus 3 equals -1 over 2. Right, so, well, I'm still not happy with the pi over 2 times x minus 3, so I'm going to represent v to be pi over 2 times x minus 3. Then my equation becomes much simpler. Sine of v is equal to -1 over 2. Right, so my next goal is to solve for v, and then I'm going to replace v back with pi over 2 times x minus 3. So I'm going to say goodbye for now. First of all, what I need to do is I need to change this equation into the reference angle. I'm going to find the reference angle, and I need to change that negative number to positive number as well. If it's positive, we can just keep it positive. Now let's solve for r. We can use our calculator or your brain, or unit circle, whatever you want. When sine of r is equal to 1 over 2, I'm pretty sure that r is equal to pi over 6. I know that because I can draw a special triangle where the ratios of the sides are like this. And when the reference angle is pi over 6, opposite of our hypotenuse is 1 over 2. So using the r is equal to pi over 6, let's find the v at each quadrant. Because I know that sine of v was negative 1 over 2, which means that sine of v was less than 0. What does that mean? Well, it means that we have our answers in quadrant 3 and quadrant 4. So let's go to quadrant 3 first. In quadrant 3, my v is equal to pi plus the reference angle. Okay. I'm using ASTC, so sine is negative, so it's quadrant 3 and 4. And also in the quadrant 3, my angle would be like this. So it's pi plus r. In this case, pi plus r would be pi plus pi over 6, so that's 7 pi over 6. And then in quadrant 4, using the similar idea, it's going to be a bit less than r. The full circle minus r, so it's going to be 2 pi minus r. Now, 2 pi minus pi over 6. 2 pi is 12 pi over 6, so 12 pi over 6 minus pi over 6 will be 11 pi over 6. Alright, so we found our answers in quadrant 3 and 4. V is equal to 7 pi over 6 and 11 pi over 6. Alright, so I think my final answer, not final answer for V would be 7 pi over 6 plus 2 pi n for the general solution, and 11 pi over 6 plus 2 pi n. So we reached our end with V, but now we need to actually find x, right? So let's bring back x, pi over 2 times x minus 3. So we have pi over 2 times x minus 3 is equal to 7 pi over 6 plus 2 pi n. We also have pi over 2 times x minus 3 is equal to 11 pi over 6 plus 2 pi n. For each case, let's solve this equation. And first, I'm going to divide it by pi over 2 on both sides. Or in other words, I'm going to multiply by 2 over pi. It's going to be x minus 3 left. 7 pi over 6 times 2 over pi. Well, 2 and 6 are cancelled out, so we have 3 on the bottom. Pi and pi are cancelled out, so I have 7 over 3. Is that right? 7 over 3. And then 2 pi n, well, I multiply by 2 over pi, so pi is gone. So I think I'm going to have 4n. Adding the 3 on both sides, 3 is 9 over 3, so 16 over 3 plus 4n. Let's do the same thing on the second version. So it's going to be x minus 3 on the left-hand side. On the right-hand side, let's do a similar thing. It'll be 11 over 3 plus 4n as well. So therefore, my final answer would be adding by 3, 20 over 3 plus 4n. So I have two answers, x equals 16 over 3 plus 4n, and x equals 20 over 3 plus 4n. And of course, luckily we're allowed to use our calculator, so we can figure our answers using this calculator. What is my equation again? It was 2 left. So let's go y equals left hand side, y equals, what's again? 2 sine of pi over 2 times x minus 3 plus 6. And then y equals negative 2 sine of pi over 2 times x minus 3 plus 4. Negative. There you go. So let's find the points of intersections. I see two different numbers here. So do you think the numbers are, first of all, do they have the pattern of 4, every 4? Well, let's see, the first one is 1.3 repeating and then 5.3 repeating. So definitely the pattern of 4, the period is 4. That makes sense. And then the numbers that we got was 16 over 3 and 20 over 3. Is that part of the answer? Well, 16 over 3 is 5.3 repeating, so definitely that's yes. And then we also know that 20 over 3 is 6.6 repeating, which we have here. So I think our 16 over 3 and 20 over 3 are part of the answers. I'm happy with my results. So I know for sure that my answer is correct. Notice that the starting number, it doesn't really matter. So I can write this number as 16 over 3 plus 4n, or I can write it as 4 over 3 plus 4n. No problem with that. All right, last question. The Ferris wheel, of course, a typical sine function application question. A Ferris wheel with radius of 40 meters complete one revolution every 5 minutes. The lowest point of the Ferris wheel is 5 meters above the ground. All right. So let's draw a sinusoidal graph of the situation, starting with the person getting on at the bottom of the wheel at the time t equals 0, and assume that the person gets to ride for 2 revolutions. Let's try to graph this thing. So I have no idea about what the period is, what the amplitude is, but I think I can still try to graph something. So this will be the height in meters, and then it's going to be time in minutes. So apparently we start with the person getting on at the bottom of the wheel at t equals 0. So we want to plot that point first. Well, the lowest point of the wheel is 5 meters above the ground, so that seems like the entrance level of the point of the wheel. So let's plot the point like this, and it's going to be 0, 0,5 at this point. And then we're going to complete one cycle. Well, let's use our common sense to figure out how high do we go? What is the maximum height we'll reach? Well, the Ferris wheel is 40 meters in radius, so I think we can draw a graph Ferris wheel like this, a radius of 40 meters. And this Ferris wheel is automatically placed 5 meters above the ground. So if there's a 40 meters above as well, then how high can you go? I think it's quite obvious. We can reach the maximum height of 85 meters. So let's say we reach that point, 85 meters here, or sorry, height is 85. I don't know the time that we reach that point yet, but I do know that also that because it takes 5 minutes to complete one revolution, I'm gonna go down to 5 meters of height at 5 comma 5. So then what do you think? Well, obviously it's going to be reaching the maximum point in the middle of 0 and 5. So I think we can reach the maximum point at 2.5. Now let's continue to graph the rest of it. And it seems like the question wants me to draw at least 2 revolutions. So it's going to hold graph like that. And if I plot these 2 points as well, it'll be probably 7.5 comma 85. And then 10 comma 5. So it probably takes 10 minutes in total to complete 2 revolutions. Right, so I have the graph myself. Now let's find an equation of it. We already did that in the previous question, so let's do it much quicker. So knowing that the maximum point and the minimum point, so I know that my amplitude, well, actually let's find the period first because that's easier. Well, my period is, well, we already know from the question, period is 5. So that means that my v value will be, if I use the formula, period is equal to 2 pi over b, so then 5 is equal to 2 pi over b, then b would be 2 pi over 5. Then what about my amplitude and the midpoint? Well, I think I can find the amplitude very quickly. Amplitude is equal to maximum minus minimum divided by 2. So that's 85 divided by minus 5. So it's 80 divided by 2. That's 40. Well, guess what? Knowing that the radius of this Ferris wheel is 40 meters, so the amplitude is 40. Guess what, right? So that means that my A value will be 40. Finally, the midpoint, not finally, sorry. The midpoint, we find it by doing this maximum plus minimum divided by 2. So that's like the middle of this Ferris wheel. We can actually see it. The answer should be 45. 9 over 2, and it's 45 D, which tells me that D is equal to 45. Okay, so now we just need to find a phase shift. Well, what is the phase shift? Well, I'm going to use the cosine graph, obviously. So I know that my cosine graph probably peaks at 85 like this. So then the phase shift would be to the right by 2.5. So which means that my C value will be negative 2.5. Let's combine those information to find that equation. Y equals 40 cosine of 2 pi over 5 times x minus 2.5 close plus 45. Once again, I'm going to confirm myself that I'm using my calculator. Y equals 40 cosine of 2 pi over 5, open bracket x minus 2.5, close, plus 45. Alright, well, let's change my x-axis. Well, it went from 0 to 10 on my graph, so let's go 0 to 12, let's say. And then my y-axis goes from 0 to 85, so probably like hundreds. Let's go 0 to 100. Alright, so this graph looks really good, and I just want to make sure that all the points are there as I have planned it to be. So I'm confident that this graph indeed represents my situation. Part C, determine how high the person will be after riding for 3 minutes. Basically, the question wants me to find, hey, what if my, oh my bad, I should D of t, no, not D of t, H of t. So basically, the question part C is asking me, hey, what if I put t equals 3? So what I can do is I can plug in 3 minus 2.5, 0.5, that's a lot of work, and I don't like doing that. I'm just going to use that. What I can do here, using this note, is I'm going to graph x equals 3 and find the point of intersection. So if I put in that point, so I know that when x is 3, my y value will be 77.36, or approximately 77.4 meters. See, so when t equals 3, h of 3 is approximately equal to 77 point, what was it? 77.4 meters. Last question, it's at a very similar level. When will the person first reach 80 feet? So that means that we solve the equation, h of t is equal to 80. So I could do all the stuff that we just did, solving the equation. So let's just do um, y equals 40, 80, right? So this person reaches the height of 80 multiple times throughout this ride, but the first time we reach that is after 2.097, so 2.10 minutes. So I think those are my final answers. Right, thanks for listening to this video, and hopefully you prepare and you can watch it multiple times to keep your thought process clear and next week prepare for your upcoming assessment next week. Good luck.